Hi there. Welcome back to Weather Analysis with Mr. CB. And in this video, we're going to be talking about NBM. So, what does that stand for? National Blend of Models. It's defined as a nationally consistent and skillful suite of calibrated forecast guidance based on the blend of both National Weather Service and external numerical weather prediction model data and post-processed model guidance. So, in short, it's gonna, oh, well, what's actually, it's gonna look something like this. So it kind of looks similar to Moss that we talked about in the last video, but we have a little bit more information provided and it's a little bit more updated or relevant to today compared to Moss, which is really being faded out. Um, but we're just going to talk about how to read it. But there are different um, types of NBM. So we're going to mostly talk about NBS, which is the most common version, which is the short version. It has intervals of time in 3 hours, um, and hours are covered from 6 hours after the model is ran to 72 hours after the model is ran. So here is an example of, as you can see, NBS. Now, I know this looks kind of crazy. If you're looking at it, it just looks like, oh my gosh, that's a ton of numbers. This is crazy. But really, if you just know what all of the side rows mean, um, it's pretty easy to figure out what any of the numbers mean. So we'll just start out with, I'll move this down here now. Um, we can see the station right there. That is Walterboro, South Carolina, in this case, and we can see that this is a process or a component of NBM, and the date that the model was ran was December 10th, 2025 at 0Z UTC, and we can see the date here. So we have December 10th, December 11th, December 12th that's displayed. It starts at 6 hours after the model was ran. Then there's 9Z, 12Z, 15Z, 18Z, 21Z, and so on. Um, so that's the time UTZ. Um, and FHR is forecast hour. And so it's the number of hours after the model was ran. So as you can see, the numbers align for this, but obviously it doesn't restart. So it's just 24, 27. And as we can see, it goes up to 72 hours out. So then we have TXN. TXN is the next row, and it is going to tell us our high and low temperature for the day. But it's important for a lot of these numbers to note that it is what you see, the number that you see, and if there's a gap in between, it qualifies as what was before it. So what I mean by that is 28 is the low right here. The low is always at 12Z, the high is always at 0Z. The low is going to be for not this time period, but for the time period before it, the gap before it. This 58 high is actually really going to be the high for December 10th. This 36 is the low for December 11th. This 51 is the high for December 11th. So it always is for the gap before it. Um, Not every single row are we going to talk about in this video, just the most important ones. So we're now going to move on to TMP. TMP is going to be the temperature in Fahrenheit at that specific hour. TSD is temperature's standard deviation. So the higher the number, the more variance that there is. Um, and the temperatures that the models that could be ran. So there's the higher the number, there's less confidence in what that temperature might be. Dew point, DPTs, that's what that is. And obviously, the closer that that is to TMP, more if they're the same, we have reached saturation. And the closer they are, the more moisture that we have. Sorry. DSD is the dew point standard deviation, so it functions the same as the TSD. Next, sky is the percent sky cover that we have. So it's percentage, it's not in octas like it was for um, Moss. And it's important to note that some of these changes were because it's a little bit more easy to read for the general public than if they didn't know what octa was. So percentage is pretty easily digestible, and you can see that there. Next, we're going to talk about um, we have WDR, which is wind direction. It's in degrees, and you need to add a zero to the value that you see. So this means 0 degrees, 240 degrees, 240, 230, 250, 270, 290, 310, and so on. WSP represents wind speed in knots. And other SDs that you see here are once again standard deviation. GST is wind gust in knots. P06 is going to be, um, oh, it's not on the slide for some reason. I don't know why it's out of order. But, oh, I don't guess it's on either slide. But we already talked about that in the last video, but that's going to be our 6 hour precipitation. And as you can see, um, that is 0, 1, 0, 1. Really, zeros are just essentially, or z ones are really just the same as zero. It's really just a slight, almost error that it is not error, but if you see a one, basically it really means zero, essentially. Then P12 is 12-hour precipitation, and uh, Q06 and Q12, that's the 6 hour and 12-hour QPF. Remember, that's the liquid precipitation, liquid equivalent, in hundreds of inches, and that's zero in this case. And notice for the sky cover is very low, and so it would make sense that these values would all be zero because there's not anything really forming. Um, so then let's move on. DUR is the duration of precipitation that's expected from the time interval before it. So remember before, but of course it's zero. This probably wasn't really the best example, honestly, because all this stuff is zero, but it would be just the number of hours that you're expecting precipitation to be going on. TO3, 6, and 12 are the 3 hour, 6 hour, and 12-hour probability of thunderstorms. And of course, in December, um, yeah, it's probably makes sense that it's zero. All right. Now, PZR, PRA, PSN, PPL, those are very important, and they are all zero in this case, which isn't very useful. I guess I should have looked at the data before I did that. But these are these four right here. And it's important, these are very important because they're going to help you know if there is precipitation, what type might it be? So PZR would be freezing rain, not very good, kind of um, important to know if that's the case. PSN is the probability of snow, PPL, probability of sleet or ice pellets, PRA, probability of rain. SO6 is the 6 hour snow amount and 1/10 of an inch. Important because it's other things we have 1/100ths. This is 1/10, tenths of an inch. But of course, it's all zeros. Um, Now we have snow level. So that is going to tell us the height above sea level at which precipitation is still snow. Because of course, the temperature is going to be lower, higher in the atmosphere, and so it might be snow at first, but then it changes to rain. Um, and so you can see if the snow level was zero, then you would obviously know that means it's getting to the ground. But in this case, we have values that are all above zero, and that's in hundreds of feet. So that means 1,900 feet, 2,400 feet, 4,700 feet above the surface. And yes, it does make sense that in this right here where we have the high 60, it makes sense that we have a higher snow level when we have a higher surface temperature. Next, I06 is the 6-hour ice amount. Of course, it's zero for that. CIG is going to be the ceiling height, which represents the lowest height of broken or overcast clouds. It's in hundreds of feet. But if it's negative 88, it means it's unlimited. So it's all negative 88 all across. So that means that um, the ceiling height is unlimited all throughout this if you see a negative 88. IFC represents the probability of ceiling height with IFR, which means instrument flight rules needed. So this would be important for pilots. So basically, if there's a ceiling less than 1,000 feet, and you can see here the probabilities. We have mostly 100s, and the ceiling height is unlimited. Oh wait, I'm sorry, I was looking at visibility. Instrument flight rules right here. So no, all the values are low, of course, because the higher it is, the more chance they need to use the instrument flight rules, and it's harder to see. But a lower value is good. LBC, or sorry, LCB, ugh, lowest cloud base, in hundreds of feet. And you can see that's going to be 16,000, 24,000. The numbers kind of run together when there's three digits like that. And then you even have a case here, negative 88, where it's unlimited. Oh, now visibility, that's what I was accidentally looking at before. The visibility is basically tenths of a mile. So we see almost all 100s. If you see a 100, that means the visibility is greater than 10 miles. So very good visibility all throughout here. Um, then IFV is the probability of a visibility less than 3 miles and very low probabilities in that case. Um, now here, this is 2.1 miles. So we have here a higher IFV. That makes sense. Um, MHT is mixing height. That's where the top of the PBL is. It's important for convective processes, also important for fire weather forecasting. And it's in um, hundreds of feet. And this value is going to be higher in the summer, but it's relatively low throughout this run. TWD is transport wind direction, and it's how winds change with height. If you see a value of zero, it's considered calm, and you add a zero to know the direction. So 40 degrees, 40 degrees, 100 degrees, 210, 170. TWS is transport wind speed, and that's in knots. So as we're going up. And then HID is what's called Haynes Index. And it's basically the potential for wildfire. It has a range from 2 to 6, low to high. So slightly higher values here, 4, 4, 4, 5, um, represent it helps to represent or detect instability and dryness. Um, Now that's kind of being blocked, but the last thing is SOL, which is solar radiation. All right, so that's everything. Now that was MBS. There's also MBH, which is less common, but it's just going to be every hour. So the only difference is that there's going to be some areas where there's O1. So like instead of just PO6, P12, you'll have a PO1 and different things like that. Then there's NBE, which is extended. And in that case, we have extensions, so we might even have P12, P24 added. And that's going to be it for this video. And with that, that concludes the first part of weather analysis. And if you've been enjoying this series, I will pick up back on this in about a month, and we'll start back up with the second part of weather analysis. And additionally, I'll be starting some severe weather videos at that time too, so stay tuned for that. Thank you for watching.